Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Good morning, dear students. Today's lesson is about the shapes of atomic orbitals. What are these orbitals? As we know that an atom has a spherical center of nucleus at the center. As you know that it has two regions, inside the nucleus and outside the nucleus. Electrons revolve around the nucleus within their orbitals. So these orbitals are the probability of finding an electron is maximum, or these orbitals the space where an electron can be found. An electron bound to an atom is acting both wave and particle properties. According to the de Broglie principles, electrons have a wave nature when they rotate around the nucleus like a wave. This principle it is known as the de Broglie wave and particle dual nature. The probability finding an electron around a nucleus, it can be calculated, which means relative probability indicated by series of dots. The probability of finding an electron in an atom within their orbitals, it is like a dot. So it makes a cloud of an electron. Cloud of electron is the probability of finding an electron which revolve around the nucleus within their orbitals. So the shapes of atomics are very important. Why they are very important? As you know that chemical bonding is formed by sharing or transfer of electrons. By sharing in case of covalent bonding and transfer of electrons in case of ionic bonding. So these electrons are shared or transferred between two atoms. So it forms a chemical bond. That's why we are studying about the shapes of atomic orbitals. The shape of an atomic orbital, it is determined by one of the four quantum numbers. As you know that there are four quantum numbers. The first one, the principal quantum number, and which tells us the energy of an orbital. The second fourth quantum number, Azimuthal or angular momentum quantum number, which is represented by L. It tells us the shape of an orbitals. This azimuthal quantum number, it is from 0 up to n minus 1. Its value is from 0 up to n minus 1. For example, if the n value is 1, L equals to 0. N is the energy level. If n is 1, the first energy level. If n is 2, the second energy level. If n is 3, third energy level, and so on. But this L value, if it is 0, it is S subshell. If it is L value is 1, it is P. If L value is 2, it is D, and if L is 3, it's F, and so on. Based on this, it tells us, the L value tells us the shape of unorbitals. The shape of anatomic orbital determined by this one of the 4 quantum number, that's called angular quantum number, angular momentum quantum number, or azimuthal quantum number. Each value of L is assigned a letter S, P, D, and F. S, value of L is 0, P, the value of L is 1, D, L value is 2, and F is value is 3. We can calculate the number of orbitals. We can calculate the number of orbitals by using 2L plus 1. If L value is 0, 2 times 0 plus 1 equals to 1. It means an atom that has 1 orbital. An orbital, it is represented by box, and the electrons are represented by arrow, like this. Arrow upward tells us spinning of electron clockwise, and arrow downward, it tells us spinning of electron anti-clockwise. So it has an orbital 1. An orbital has a maximum of 2 electrons. It cannot have more than 2 electrons. So the third quantum number ML, which is tells us the orientation of these orbitals. Its value is from minus L, 0 up to plus L, which is tells us the orientation of the orbitals. As you see, from P has 3 ML values. For L equals 0, S has M equals to 1 orientation, 3 orientation, and this one it has 1, 2, 3, 4, 5, and this one has 7. As I told you before, L value has 1 orbital, maximum of 2 electron. S subshell can have 2 electron. L equals to 1, it means P orbital. 2 times 1 plus 1 equals to 3. L subshell can have maximum of 3 orbitals. Each of them can have maximum of 2 electrons, can have maximum 6 electrons. P subshell, it has maximum of 6 electrons. The same for D. L value is 2. It means D subshell, 2 times 2 plus 1, 5 orbitals. So each of them can have maximum of 2 electrons. So D subshell can have maximum of 10 electrons. When you see F subshell, L value is 3, 2 times 3 plus 1, it's 7 orbitals. Each of them can have maximum of 2 and totally 14 electrons. Generally, L value 0, it means a subshell maximum of 2 electrons here. L value 1 means P subshell, it has 3 orbitals, maximum of 6 electrons. L value D, it means D subshell, 2 times 2, 5 orbitals, maximum of 10 electrons. L value 3, it means F subshell, maximum of 7 orbitals. It can have maximum of 14 electrons. This minus 1, 0, and plus 1, it is the magnetic quantum number ML value, which tells us the orientation of an electron. the fourth quantum number, that's ms, which has value plus 1 over 2 or minus 1 over 2, which tells us the spinning of electron plus 1 over 2 for clockwise rotation around the nucleus within their orbitals, minus 1 over 2 anti-clockwise rotation around the nucleus. Generally, the arrow represents the upward one is clockwise rotation, and the downward it shows that anti-clockwise rotation. So an atomic orbital can also be represented by a geometrical shape. What is this geometrical shape? It is the probability of finding that's maximum. For example, the s orbital can be represented by this spherical shape. As you know, that if it is 1s, it is represented by this spherical shape. This is s subshell or orbitals. So electron will be found around here. For p orbitals, it has a dumbbell shape, you know dumbbell, with 3 orientations around the x-axis, y-axis, and the z-axis. So these orbitals, p has 3 orbitals, as I showed you before, px, py, and pz. These p orbitals, it has a shape like this, which look like a dumbbell, right? The p orbitals have 2 lobes, one lobe here, the other lobe here. So this electron will be found around these lobes in either sides. The nucleus and the node located, the node is, this one is node. There is no probability of finding an electron. There is no electron around this node. So these 3 p orbitals are oriented around the x-axis, y-axis, and z-axis. Px oriented along the x-axis, py it's along the y-axis, and pz along the z-axis. So how these 3 p orbitals are differ? The 3 p orbitals, there is no difference between them, but when the principal quantum number increases 4p, 5p, 6p, only their lobes larger size become and their node becomes increased. As I told you before, these 3 p orbitals are labeled on the x-axis here. This is px, it's located along the px axis. This is the one lobe and the second lobe. Electron will be here like this. This is nodal value. No electron will be found here, px. This is one is pz, z-axis. This p value located along the z-axis. Py, it is located on the y-axis. Generally, these 3 px, py, and pz has 3 orbitals p. They are belongs on the axis. But when they become higher, only their lobe size becomes increased like this, and their nodal value increase. That's their only difference. Their orientation is another difference, but these 3 orbitals they are the same energy orbitals. They are called degenerate orbitals. What about the D orbital? D orbital, it is resembles, or it has the shape of two dumbbells, or we can say the clover leaf shape. If you know that the clover leaf shape has a shape it has shape of like this, two dumbbells shape. But as I showed before, there are 5 D orbitals: dxy, dxz, dyz, and dx squared, y squared, dz squared. It has 5 orbitals. From these 5 D orbitals, the 4 orbitals dxy, dxz, and dyz, these orbitals are oriented between the axis on the plane, not the axis. dxy, they are oriented on between x-axis and y-axis. dxz, they are oriented between x-axis and z-axis plane. And dyz, they are oriented between y-axis and z-axis. But the two dx squared and y squared, dx squared and y squared, they are oriented along the x and y axis like p orbitals. But dz squared, it is oriented on the z axis, and it has a donut wrapped around the center. Let me show you the picture. The 4D, 5D, and 6D. These are the 5 D orbitals generally. dxy, as you see that this is x-axis and this one is y-axis. It is between the axis. That means the two lobes are between the axis on the plane of x and y axis. dxz, it is between x-axis and z-axis plane, not on the axis. dyz, it is on the plane of y-axis and z-axis. This is y-axis and this one is z-axis. It's between the two plane. But the x squared and y squared on the axis of x and y. Here is on the axis of y, x-axis, and here is on the axis of y-axis. dz squared is derived from dx squared, z squared, and dy squared, z squared. That's why it has its shapes like it was like this. So this generally it becomes like a donut wrapped around the center. So the probability of electron around here is maximum. The next one is f orbital. As you see that f orbital have more lobes and nodes than d orbitals. It's very complicated shape. Generally d orbital is more complicated than p orbital, and f orbital, it is most complicated than d orbitals. So when their energy level increases for each of them, their lobes, except s orbital, their lobes and their nodal values increase, but their shape does not change. Thank you for your attention. Generally, it is when we see them together, this one is 1s, the first 1s, the second 2s. 1s, 2s, and 3s, they are differed by their nodal value. 1s does not have node, 2s have one node, 3s have two nodes. This and this one is 4 3s, nodal value. For space, it is this one is the nodal value. P orbital is the 4p, the 3p orbitals together, 1, 2, and 3 p orbitals. They are 2p orbital. The nucleus is at the center of the axis. For more information, please watch the following video. Goodbye, students. Thank you for your watching and listening. I will see you next class again.